Hi Conrad, this is a quick demonstration of the spline toe plate control. So we've got a job loaded. We hit the toe plate button, which shows us the two spline curves. We can then adjust them as required. We also have the ability to select the lines between the vertices. They can sometimes be an easier way to edit. Once you've changed the positions of the vertices, you hit the toe plate button again, and that redraws the spline curves. You can continue to adjust them as required. Each time hit the toe plate button to get the curves redrawn. When you're happy with the result, you would hit the exit overlay, save changes. This does two things. It turns off the overlay mode so the vertices disappear, gives you your final spline curves, but it also changes the geometry relative to those spline curves. So what happens is it will take the Z elevation at each of the two spline curves and apply a linear variation between them based on the original position and the distance between them. I think this is where you have a problem in that, well, we have a problem in that I have to define the mathematics correctly and it's not currently doing what we need. You should only have to hit the exit overlay once. If you hit it again, it does exaggerate the geometry. This isn't of any practical benefit, but at the moment I'm keeping this, and rather than limiting it, in order to allow it to show where the adjustment is taking place. So you can see that the geometry is being raised very much in relation to where the spline curves are. The other problem with this is once you hit the exit overlay button, the geometry is changed. At the moment you can't go back, and it might be required that we have one level of undo. So if you apply a change and you don't like it, you can revert back to what it was previously. How we handle the variation, I think, is yet to be determined. Clearly picking the Z elevation at the heelmost spline curve can have an incorrect result if you're further back in the foot and beyond the raised section where the toes are.